Hello everyone, this is the first lesson recording for IM2, November 12th, 2020. What are we doing today? We are going to be solving some application problems involving right triangle ratios, and we're going to be using right triangle ratios to find angles. So quick history about trigonometry. Well, trigonometry comes from the Greek word trigonon, which means triangle, and metron, which means to measure. So it's really a measure of triangles is the literal translation, which is a branch of mathematics that studies relationships between side length and angle of triangles. And the field emerged in the Hellenistic world during the 3rd century BC from the application of geometry to astronomical studies. So they did a whole lot of studies on astronomy in the olden days. Why did they do that? Because that actually helped them navigate. They did a lot of traveling um, on the sea, and that by looking at the stars, they could actually figure out where they are and where they need to, which direction they need to go, and so on and so forth. Something that we do not need to rely on these days due to GPS. So why do we care so much about trigonometry? Because it's a really powerful tool. So if you give me just one angle and one side length, I can figure out the rest. So for example, I am given this 59 degrees, and I am told that this length is 16 degrees or 16 units. Then I can figure out the height, provided that this is the angle that is measured is perpendicular. So we have a right angle triangle. We can figure out the height of this triangle. We can figure out the hypotenuse. We can also figure out the other angle. All right, so for example, if we are given this problem, you know that the angle of elevation, this is a study of angle of elevation. Angle of elevation is the angle that it makes to the horizontal. In this case, it's 35 degrees above the horizontal. So this is the ground level horizontal, and it's making 35 degrees there. And the angle of elevation can be positive or negative depending on whether you're measuring above or below the horizontal. And we're told that the distance from this person to the Eiffel Tower is 425 meters. Can you figure out what the height of the Eiffel Tower is? Well, we know how to do this because we know that this is my 35 degrees is my reference angle, and we have the adjacent side. So I am going to write adjacent right there. And we're looking for the opposite side of this triangle. So what is the trig ratio that we can use that involves opposite and adjacent? That's tangent. So that means tangent of 35 degrees is going to be opposite. Let's call this x because we don't know what it is. X divided by 425. And we can look up tangent of 35 degrees from our table, which tells me tangent of 35 degrees is 0.7002. So 7.002 is equal to x over 425. Now multiplying both sides by 425, I get x is 0.7002 multiplied by 425, which when I use the calculator, I get 298 meters. So I know that from my calculation, I can approximate the Eiffel Tower's height to be approximately 298 meters. So now you're going to go on to some Desmos exercise. The link will be provided for you, and it's on practical trigonometry problem solving. You're working from 1 to 16. So you are working on your own, 1 to 16. I did use the breakout room during the class time with the partners that you requested. So hopefully that worked out well. Here is a picture of clinometer. This is the tool that you can use to measure the angle of elevation and angle of elevation. So how do they do that? You start looking up to whatever you are measuring, and that the angle is you're taught what is the angle of elevation is. Okay, so please pause the video and do the card number 1 to 16, and I am going to go through them slowly myself. But it's very important that you get to try it yourself. Okay, the first card is just playing around with the tool. So if here the blue device is your tape measure, use it to measure distance. Try adjusting the movable points. So these, both the blue dots, they are movable. Oops. So I can move these like so, and I can move this up and down as well. So say if I wanted to move, measure how far the trees are, how far apart. Say if I wanted to measure from this point to what looks like the center of the tree. Okay, to me, it's 7.1 meters away. Okay, so, and of course, if I was measuring from the edge of the tree to the edge of the tree where the tree starts, that's going to be different, right? I get 6.4 meters. So depending on how you measure, you would get different numbers. All right, the next card, this is the red device is your clinometer. Remember, clinometer is the tool to measure the angle of elevation or something like that. Try moving it around and slide the green dot. So you can move this red dot like so. Okay, and I am going to move it right at the angle measure that we want to measure. Okay, and then I can move the green dot, which will measure the angles. Okay, so I can, all right, so what is the angle here? That looks about right. So my guess is that angle measure is 53 degrees from what I've just done. Okay, all right, then moving on. Okay, you're going to use those tools now to measure different triangles. So use your measuring device to measure the orange angle. Record your result in the table. So if I was to measure the orange angle, I need to move this red dot to the vertex. Okay, and then I need to move my green dot to so that I can start measuring. Okay, so that's right here. It's 18 degrees. It gets bigger and bigger and bigger and bigger until there. Okay, so I measure 53 degrees. So orange angle is 53 degrees is my answer. Length of the hypotenuse. Okay, the hypotenuse, which is the hypotenuse? It's the side opposite from the right angle. So hypotenuse is the 10 meters that we're told. So it's 10 meters. Okay, now we're trying to find the height of the triangle. Height of the triangle is this distance here. How will we do that? Well, we know an angle and we know one of the side length and it's a right angle triangle. That means we can figure out the rest of the measurements. So what will we do? Well, let's talk about that. So we have the hypotenuse, okay, and we're trying to find this side length, okay, and let's call that x. And x is in relative to the reference angle. This is across from the reference angle. So that means this is the opposite side. So we're dealing with a trig ratio that deals with opposite and hypotenuse. Which is that? That's the sine, isn't it? So we can write sine of 53 degrees is equal to opposite, that's x, over hypotenuse, and we're told that was 10. Okay, and if I use my trig table, I know that sine of 53 degrees is 0.7986. 0.7986 is equal to x over 10. So I am going to multiply both sides by 10 so that this goes away to giant 1, and x times 10 times 0.7986, that just means you just need to move the decimal place 1 to the right. So you get 7.986. So the height of the tree is rounded up. It is going to be rounded to the nearest meter. It will be 7.986 meters. And since the height is in meters, I am going to round it to the nearest meter. And that's going to become 8 meters. And that's my answer. So 8 meters. Check my answer and it will check it for you. Does it look right? Okay, good. Then let's move on. All right, then this time use your measuring device to measure the orange angle width and the width of the triangle. Width is this distance, right? And record the results in the table, and then use the right triangle trigonometry to calculate the height of this triangle. So again, we're looking for height. We're looking for height, but we can measure some of these measurements. Okay, so let's figure out what the angle is. Okay, let me move you. All right, so put it there. Okay, make sure that dot is centered. Do you see that right here, the dot is not centered at the vertex? Or here, the dot is not centered at the vertex. So I need this dot to be centered at the vertex of the triangle so that my measurement is going to be accurate. So that looks better. All right, then I am going to move you like so. Okay, until it is flush. There we go. That looks pretty good. Okay, what do you think? Oh, maybe 53 will be better. Okay, so then I know the orange angle is again 53. Okay, and then what about the width of a triangle? That's for that I am going to use this blue dot. Okay, so I'm going to move that so that it's measuring here to this vertex of the triangle. Okay, so not quite at the vertex. There we go. All right, so it tells me it's 3 meters. Okay, width is 3 meters. Okay, what is the ratio that I'm going to be dealing with when I'm dealing with this? Is the adjacent. It's right next to the reference angle. So this is adjacent and this is the opposite of the reference angle. So what is the trig ratio that deals with opposite and adjacent? That's tangent. So tangent of 53 degrees is equal to x. That's the opposite of adjacent. Okay, and I know that tangent of 53 degrees is 1.3270. 1.3270 is equal to x over 3. So from here, I am going to multiply both sides by 3. So then I get x is equal to 1.3270. 1.3270 times 3 is equal to 3.98. Okay, so 3.98, if I round it to the nearest meter, that will be 4. So I'm going to write 4 here. Okay, and then I'm going to click on check my answer and it looks correct. All right, then go on to the next card. Okay, calculate and record the hypotenuse here. Okay, so now this time, let's orange angle is measured for us. It's 53 degrees. Width of the triangle is 3 meters. And the height of the triangle is 4 meters. Length of the hypotenuse. Can you figure out what the length of the hypotenuse is? Well, what do we need to use? Well, yes, we could use one of the trig measures, but since we know the both of the side measures, we could just also use Pythagorean theorem, couldn't we? So we know that this is 4, this is 3. Okay, if that is the case, then we know that the hypotenuse, let's call that x. So x is hypotenuse, so that's 3 squared plus the other leg squared is 4 squared is going to be hypotenuse squared. and that's 9 plus 16 is equal to x squared. 9 plus 16 is 25 is equal to x squared. So taking square root of both sides, x is equal